Oh, gentlemen, we've got ourselves a treat el special, as my buddy over there, Mr. AVE would say. That's his one of his catchphrases. It's gonna be a fun day for all of y'all. First things first, look at this little guy. Oh, it's so cute. What we've got here is a little Star TX250. We've all seen a million of these. It's got two Toshibas in it. It does have, definitely for sure, positively, without a shadow of a doubt, one transistor blown out of it, smoked. The 10 ohm smokes, have gone on to the 10 ohm gods, the sacrificial lamb. We're going to put HGs in here, so that means just basically a transistor swap, power wire upgrade, and a little bit of a tuning change to make this work optimally with the HGs. So it's no big deal. I'm going to set that aside for a moment. But I want to get to this right up off the hop. Now I know that you guys all clicked on this because you've seen the name in the title. It is a Carl Belt 2x4. This is the first one I've had show up here for me to repair. I've got a couple others that are here now. I want to say right off the hop, and you guys should know this, that if you are clicking in to see me sit here and talk smack about this amplifier or this company, you are going to be disappointed. I have made it a company policy almost a decade ago that I don't ever say anything negative about anyone. Not that there's anything negative to be said about this company or this piece of equipment. Okay? It's not going to happen. I'm a repair shop. So therefore, I don't need to sit here and talk bad about anybody to make myself look better. It's not how this works. My job is to sit here and repair the amp. So I want to make this very clear up front from the beginning that I'm not going to have anything negative to say about Carl Belt or the amps. It is just another piece of equipment, just like everybody else's stuff that I work on that comes here. And believe me, I have worked on everybody's stuff because it all breaks. Now, this situation right here, which we'll get to in a few minutes, is a common problem with this particular style of build, and it has nothing to do with the manufacturer. Just going to say that up front. No, we are going to go through it. We're going to cover it top to bottom. I personally am grateful that they're back in business. What I mean by they is, well, Carl, the original owner of X-Force, before you know who got involved and, well, made this label turn blue and then the quality went in the toilet and then, yeah, well, we all know what happened. Either Carl or White Cloud or one of the guys built this over there, so I can't wait to get into this. My first major complaint when I talked to the customer on the phone, I was like, hey brother, this little 50 amp BS clip is will not cut the mustard. So we're going to upgrade the clip to 100 amp Anderson. Now, 2x4s pull about 110, 120 amps, depending on how you run them. This one's got sideband in it, so it's going to be a full 125 to 130 amps worth of current load. So I can tell that by looking down in there. I can see the load resistors for the biasing circuit, the sandstone wire wound inducted, ceramic enclosed resistors. Everybody calls them sandstone. So let's get with it. Let's do the Transistor first, and then we'll come back around to this. I just wanted to really make that clear. Okay. It's my job to repair the amplifier. It's not my job to talk shit. And I'm not doing it here. I'm not starting on this one. I guarantee you. I'll see you. Let's get on with the Transistor. So this is a ass-on point of view of this little TX250. This is a side-on point of view. And then full frontal, full nudity point of view. So we're going to look at our 10 ohm smokers. This resistor is heavily discolored. This one has been flat out replaced. So now what most people do is they follow themselves visual and logic dissension. What I mean by that is they're going to run the amp, all of a sudden it quits. Oh, well, let's open it up and see if there's anything visually obvious to why it quit. And then look around and look around and look around and they'll go, oh, look, hey, this one resistor's all burnt up. Well, this resistor is an indicator that there's something else wrong in the amplifier, and it's usually that this transistor has faulted and shorted open to ground. Okay? And this resistor goes up as a result of that. But then they'll see that this resistor is not burned, and they think, well, maybe, just maybe, holding out hope, they'll cross their fingers, they'll cross their legs, they'll do the happy I gotta pee dance, and they'll think, maybe, if I just replace this resistor, it'll come back to life. No, that's not how this will work. It will never work. It's never going to work. I've had one guy in my entire professional career that claimed on the internet, well, man, this resistor burned up, and that's the whole reason the amplifier quit, and I changed that resistor, it went back to working. You can claim anything you want on Facebook. You can claim anything you want on the internet. Definitely can. But sticking your head up your butt does not make you anything more than a human ostrich. Okay? If this resistor goes bad, it usually tells you that this transistor is bad. And to stop running the amplifier, because this transistor is most likely still good, it's just we've had a problem over here. What people do is they'll change out this resistor thinking that they're being the backyard mad scientist. They'll go put it back in their vehicle or on their power supply at their house. They'll key it up and run it a couple more times and in turn kill this transistor as well. So in this particular application, because it's got Toshibas in it and the cost of the Toshibas is well over $200 a piece now, you went from costing yourself a couple $100 to costing yourself like $400. Just like that. By deciding that you wanted to change this one resistor. If the 10 ohmer is burnt, that means the pill is bad. Okay, instead of making you guys sit here and watch me take this apart, I'm going to go ahead and I'm going to rip this down, and I'll probably come back about the time when I'm ready to pull the transistors out. And let's test them and let's find out exactly what happened. I tell you right now, mark my hands, word to God, Mother Jesus, Holy Pearl, and Smack, that I firmly believe that this transistor is gone, and this one ain't too far behind it. If it's not already dead from when they changed out this resistor and then tried it again and seen if they, yeah. Okay, moving on, moving forward. I think this is a good place to bring you guys back in at. So we got her stripped down basically where we want her to be. Throw that paper towel there. Let's go in here, and this is the one that did not have the burned up 10 ohmer. If you guys can remember from about 20 seconds ago, which is about 30 minutes ago to me, 20 minutes ago to me. Go ahead and reflow this, just in preparation. Now the goal is to get the transistors out of there and not screw up the little copper cladding that's underneath transistor tabs. Okay, we're going to set that out of the way for the moment, because I'm going to take it out, I'm going to wash it, and we'll make it all look pretty and new. Let's take our very basic transistor checker here, which has been surprising to me to watch people have a backlash about this tester. There's people that are technicians that feel that this is a horrible tester. I strongly disagree. This is about 10-year-old tech at this point. The first one I got was about 10 years ago, and it was the Atlas DC55. This is an amazing tester for what it is at its price point. They're just a few dollars, like I think they're like 75 or 80 bucks now. The 55 I think is only a $45 unit or something. It is a non-preferential lead hookup, and what I mean by that is you can hook up the leads any way you want. You don't have to figure out which one's base, emitter, collector. No longer have to use that side of your brain. Hook it up, hit test. And it's going to give you a general diagnosis of the transistor. This one has a gain of 20. This is the one that was over here in the amp. This one here is the one that had the burnt resistor on it. Okay, this one here went here, this one here went here in the amplifier. So it says a gain of 20, so technically it's still good. Now, if we were to take and put this on a transistor tester that would allow us to achieve what they consider to be the maximum HFE gain rating, it wouldn't run on a garage door opener battery. I think this one runs on a AAA. Very little amount of current, very low voltage. But it allows us to get the data that the transistor is still good, and it gives us a general reference number. It's not an absolute max number. And for some reason, somewhere along the line, some of these keyboard technicians have got it in their head that because it doesn't push the transistor to its absolute maximum gain structure for a leakage breakdown, because that's what we're testing, therefore it's crap. Well, I disagree. This transistor allows us to check everything. MOSFETs, LD MOS, everything. And on the LD MOSFETs, it tells you what your gate voltage you need to set for each individual device, roughly. That's a wonderful piece of test equipment that's cheap, small, and portable. I got a transistor checker over there that's the size of a regular carry-on suitcase. We can put 250 amps worth of current on the transistor if it's needed, and literally make the top go and blow it off if you want to. But for the home gamer, most of you guys, my ham radio CB buddies, this little transistor checker is brilliant and more than adequate. Chunk. So, even though the shade tree mechanic got involved and said, nah man, we're gonna put brown, black, white. Well, at least they got the right value of transistor in there. We're gonna put another 10 ohmer in there, and I bet you it come right back to life. Because somebody with a little bit of soldering skill got in there and changed out that 10 ohm resistor for this guy. You can't blame them for trying, but the fruit and the labor is for naught. Okay, so we're going to take this transistor, we're going to set it aside. Now, for most intensive purposes, this transistor is usable, for the most part. But only if you have another transistor that matches its HFE gain structure exactly. This thing here, we're going to throw it in the big bag of replacement transistors from this year. That's how many transistors I've changed just this year. Every year I do a 1 gallon baggie. And I damn near about halfway fill it up every year. So that one goes in the scrap it bin. And I know eventually I'm going to ball mill that, and we're going to get all the precious earth minerals that are in these things. That's my retirement plan. Just between you and me. Don't tell anybody, but that's my retirement plan. I got nothing else going on other than that. We're going to throw this one aside. Normally what I do for used transistors like this, since they are technically still good, but they're not new, they do have a value to them. Being that they are a Toshiba. This is a legit Toshiba, by the way. I normally assign about a $50 value to these, and then I'll take it out of the customer's repair bill. And what this does is allows me to have another transistor that is good, but the HFE gain on it is lower than normal. Normal would be brand new is in the hundreds most of the time. That's on a higher, like a 4 or 5 amp tester. That'd be up in the 100. This thing being 20, if we were to load it underneath the current load, would probably have a gain of about 45. But on the Atlas tester, it's at 20. So then, just to give you an example, I've got some Toshibas that we pulled out of the back of a Kenwood 440, of all things, and they've got a gain on the Atlas at 115, and when we load them on the actual transistor checker, they're like a gains of 160. So. But this is still good. This can go on to serve the radio world in the future as a repair transistor. That then we sell this as a discounted rate also. But we're going to set this aside because I haven't discussed with my customer what he wants to do, and technically this is his property. So We'll set this aside and we'll come back to that. In the interim, we're going to go out and we're going to go wash this. So soak in its disgustingly old beauty gore. Take a look at it. Let it sink in. Let it filter down into the brain hole. Now, we're going to set this up as my mark on where I need to set this thing. And if I can do my video editing right, I'm going to snap my fingers and it'll be washed and pretty looking again, and you'll be able to see the night and day difference. Ready? Amazing, isn't it? So we went out and we gave her a little bath. We knocked all the old flux off of it. Made it look all new again. It's so pretty. It's shiny. At some point or another, this cap has been replaced, which is real indicative of the imbalance when the one transistor goes down. Cleaned out the pill pockets really good. We've got our new transistors, our new 10 ohmers sitting over here. We've got a grommet that we're going to throw in here for our power wire upgrade. So I'm going to get on with all that boring shit, and we'll get it put back together, and we're going to hop back here in just a second, and we'll be running through this to test it all out. We're going to change our input tuning capacitor a little bit, and that should be it. Just give me just a second. We shall return. So it's all back in one piece. Give it a couple little power wire upgrades to it. Got the HG transistors in there. Did the little cutesy little quick mods that we got to do to make it work. So let's go over here and test drive this for everybody. Let's zoom on in here a little bit. Now what we got going there right to left is 1000 watt slug in forward in PEP, 1000 in average in the middle, and a 5 watt slug in reverse. Back from the Bird 10,000 watt dummy load. Let me show you what we're doing for drive. We'll take this 5 watt slug, we'll turn it around to show you our base carrier, which should roughly be about a watt. We'll dial that in right at a watt. Now we're going to jump back over here and look at this meter. Hello, whopping whole 20 watts-ish. So with all the switches out and it in high, produces with 1 watt going in, 20 watts coming out. Hello, about 400 peak and about 200 average. So let's go ahead and we'll back on out. We'll show you what we're doing here. Let's get both of these things kind of one in frame. Preamp is working. We'll turn in our dial a watt or select a bird or select a watt. And the variable on this is all the way open. Hello, audio. Hello. It's really important that we show that in the video and show that off, showcase it, let everybody see what's going on. If you don't show moving through the entire arc of motion on the variable, and in turn show it with the watt meter running, how do we know that the variable doesn't have a bad spot in it, right? I mean, it's here to get checked out. Might as well check it all the way out. So let's take a quick look at the back. This is our sideband delay on this particular amplifier. So let's turn the amp back on. Turn the delay on. Now, some people kind of wonder, I've had this asked to me several thousand times, why is it that when you turn on some Texas Stars, that they'll key up and then unkey immediately? Let's see, this will help you answer it. We're turning the amp on, turning the amp off. Delay off. Amp on, amp off, amp on, amp off. Delay back on. Amp on off. Amp on off. So what's going on is, because the capacitor is in play, this cap right here, when we flip this switch here in the back, we're bringing this capacitor into play. And as the circuit gets charged with the positive 12 volt, remember this is a positive 12 volt switch, the automatic keying circuit in here. When we charge that circuit, there's a small inrush of current that takes place. If the cap is discharged, it's going to see that positive inrush of current for a moment, and it's going to be open as it's charging itself. And it's going to cause the keying circuit to latch momentarily when you first turn the amplifier on. It was hilarious to me. I watched a bunch of people on Facebook debate this about a month ago until the cows come home, and I kept telling him there's nothing wrong with the box. The kid's in there, he's ripping his transistors out. He's the keying transistor, he's changing it like 14 times. He's like, man, this transistor is testing good, this cap tests good, there's something wrong with it. Of course, there's always the one guy that pops up and goes, well, mine's never done that, not once, not never, has it ever never done that? Okay. Did you have your sideband button depressed when you're turning the amp on and on? On and off, on and on and off, on and off, off and on and off? It would do it. And some of these were built with an auto sideband circuit in them, where this is deleted and this capacitor is fully in line all the time. I gave my opinion on it. Of course, you didn't want to listen to me, that's fine. That's the beauty and the wonderment of this country, is we're all entitled to our opinions. But this is a very good example of that electrical phenomenon taking place. Turn the capacitor off, sideband delay off. Just food for thought. At the end of the day, this thing checks out perfect. We went ahead and washed the tin up on this thing and cleaned it all up. There's a couple little scuff marks on the lid, but this thing's all cleaned up, all repaired, back to 100%. Cleaned all the switches, lubricated the switches with sewing machine oil. It's another thing. Let me cover that here. The mechanical armature that's in here, which is right up in here, you can use a little tiny bit of oil, but you've got to make sure it's the right kind of oil. And it's usually seamstress oil or sewing machine oil. It's superly fine, very light. There's no solids to it. Like, don't use WD-40, don't use gun oil, don't use a very, very fine, very refined, very pure form of oil in it. The most common thing I can tell you to go buy is going to be sewing machine oil. And just the tiniest little kiss goes a million miles. So we made sure to lube up the on-off switch, the preamp switch, and the dial-a-watt. I do it on all Texas Stars. I just don't ever show it on video. It's just a little driblet. That's all you put in there. Okay, let me button this back up and let's move on to the 2x4. Okay, here we go. Carl built 2x4. Now, I've got a special place in my heart for 2x4s, and that's only because one of the very first ones I ever had was an X-Force 2x4. 2290s, two of them, pushing 4 2879s. Now, when I left the radio world when I was a kid to go off and go work for a couple years, the biggest thing that you had in a 4-pill configuration was like a 667, and it would barely do 700 watts. We still see that today. One driving 4. One 2290 pushing 4 2879s. So when I picked up that very first 2x4 and I went, hell with a 30 watt radio, and that 1000 watt slug went to the corner, I was like, damn. And I knew I had a lot of catching up to do. 2x4, in my opinion, is a dangerous amplifier to build in today's day and age. Let me explain. Every cotton picking, CB and truck driver having red-blooded American has gone out and bought themselves one of these. Okay? Or its equivalent brother in this class. This is roughly a 100 watt radio, give or take, depending on who does it. Okay? Okay. You have your average universe now is 100 watts. This radio here was, or this amplifier here, pardon me, this amplifier here was built for a different time and a different era. This is a great amplifier if all you're going to run is a Cobra 29 that's basically stock. Here's the problem that you have, is not everybody has a stock Cobra 29 anymore either. See, back in the day when this was really popular, everybody ran a Cobra 29 that had variable power in it and had some audio mods done to it, right? Today, every Cobra 29 out there on the face of the earth has got echo in it, variable power, and then they've gone and they've upgraded, and they've got the MOSFET finals, and it dead keys 1 watt, and it swings to 60 or 50 watts, and it's da-da-da-da-da, and it's got noise toys, and la-la-la-la-la. And so they go and they get these really, really hot Cobra 29s, and they try to run them into something like this. And it's too much drive. Now, that being said, two 2290s driving 4 2879s is a little hot. So let's talk about paperwork. According to the paperwork, one 2290 produces about 60 watts average. One 2879 roughly produces 120 watts on average. Now, I gotta say this publicly, I did kind of screw up here a few days ago. I was in my own group, a guy came in there and says, I got a 2x4, how big a power supply do I need for that? And without even thinking about it, I put in there 100 amps and hit enter. Well, this thing will pull everything up to about 100 amps plus. And because it's got sideband in it, it's going to pull even more than that. So me putting in that, 100 amps should be all right. It's a little low. It should be 125, 130 amps is what you should be looking at to do this power, or do a power supply to run this thing. And any other 2x4. You got to think that, where do we have it soldered, Carl? There we go. You got to think each transistor pulls about 25 watt or 25 amps worth of power. So you got 4 transistors, that's 100 amps, and 2 more that pull about 20 amps apiece. This is about 140 amps worth of power supply to run this safely if it's modified for Class B, which this one is, so you can run sideband. Now it's nice to see an amp builder that understands that for us to run sideband, it's more than just a delay capacitor on the relay. There's a whole lot of blue label hibma jobbers out there running around for a long time that got produced that were, you know, let's see, less, pay less, get more for your money here kind of thing. It just, yeah, you can't run Class C on sideband. It doesn't work out too well. It just doesn't work out too well. They have been building the same way, these guys, for decades and decades. It didn't work out too well underneath the leadership of Arland, and so when that all fell apart, I'm really glad that Carl come back and joined us in the building community. So let's get down to the meat of this particular problem, and let's really look at it. Let me get something to prop this up. Let me grab a ball of solder. We'll prop this up at an angle that'll be easier for everybody to see. There we go. Let's darken this up a little bit. There, now everybody can see what's going on. We'll frame this up and we'll zoom on in. There's a lot of little details in here that we need to slow down and take a look at. Now, I did a video not too long ago called Tips and Tricks on How to Build Your Own 4-Pill Amplifier. And in that video, I stood there and I talked about how I like to do bias. I like to have my bias switched. I use another little relay over here to do the job. For decades, and this works okay, this is just not the way I choose to build, but for decades they used just the primary keying well, that's even broken off. We got a lot to do in here. They used the primary keying relay to switch the bias on and off. And that's what we see going on here and here. And that's what's running our load-celled resistors with our diode pack, our capacitor, and so on. Exact same circuit, just laid out a little bit differently, and it's switched. I'm trying to loop my head back around. So this is nice. This is nice to see. And what am I talking about here? Well, a lot of guys will use a little piece of 18 gauge wire, like this big of wire. Okay? Well, as we can tell here, this is like 12 gauge. This is the way it should be done. If you're going to build this style, this wire needs to be bigger than 18. This is too small. This cannot carry enough current. Where this does the job better, would be the best way to put it. I'm not a big fan of these capacitors. We're going to replace that with a metal clad. Obviously, we've had an imbalance take place inside this box, and I'm gonna. There's a telltale here. Okay, we're gonna get to it in a minute. We've had an imbalance happen in here, and we're gonna start looking at our resistors. Let's go look at our flyback resistors. We're talking about these. You see how they're slightly discolored? This is a little tail of information here. This gives us a little tip. So now if we can move this hanging up in free space, these resistors out of the way, we'll see that over here, this is our flyback for our 2-pil driver section. This is our voltage divider that they've got going on between the final section, the output of our final section, and the input to our 4-pil section. Okay. Now what has happened here is that these two transistors are dead. We know this because the 10 ohm smoke has come out of them thoroughly and with vigorous fashion down here. You got to admire the fact that they're using twisted construction on this wire. They know for a fact that this resistor is going to get hot. So because of the differentiation in output potential, the amount of drive that's coming from this 2-pil section, which has got two 2290s in it, we know that this is going to be a little bit too much for the 4-pil section. So you put this resistor in there as a voltage divider, and it literally cuts part of the current out. It doesn't act as an attenuator. It kind of acts like a shock absorber in a way. So if too much drive goes into the 4-pil section, the leftover residual wattage and power comes back to this resistor and it gets hot. Just a little bit of a dissipator. You technically cannot, you can build this and not have it in there, but then there's no place for that excess current or excess power to go, and it backs up to our output stage. Okay. Instead of putting the sideband delay over here at the relay, they have it over here at the sideband delay switch. But the thing that tells the entire story to me is this resistor right here. Why did this amp fail? It was overdriven. It's not from bad construction. It's not from shitty components. It's from operator error. This amp probably would have worked forever, but the guy that had it did not understand that this is an incredibly low drive radio. That means your dead key's got to be down at or just a hair below 1 watt worth of dead key, max 1.5 watts going in, max 30 watts peak, max. Not, oh, 45 or 50 watts is close enough, it's no big deal, it's just modulating up there. No, just look. The HG transistors, I don't care who you are, I don't care. They're not the same as the Toshibas. This is the, and listen to me when I say this. This is the closest that we've been able to come This is the closest that we've been able to come with a Chinese component to the Japanese component. But the Japanese component, the Toshiba, has a better tolerance to drive, has a better tolerance to SWR, does still have a better tolerance to heat dissipation, and does still have a better voltage tolerance. The HGs work great. They're a viable, good component. And at $20-something or $30-something a piece, whatever these are, they're way better off than the Toshibas at several $100s per unit. In the same breath, you have to understand that the components aren't quite as forgiving. They're never going to be. Until we can find a company that is willing to literally copy the Toshiba internal guts part for part, and the thickness of the wafer, and the way the wafer is designed on the inside of the transistor, we're not going to be able to enjoy the same style of operation that we've had. If you can let yourself understand that this is a component that works roughly the same inside of roughly the same style of circuit with the same amount of turns, same amount of capacitance, internally they're a completely different architecture, but they work roughly in the same circuit. That's what makes them replaceable units. You have to understand they're not quite as friendly and happy to drive. If we go look on the back of the amplifier, dead key, amp, max, 170 watts, peak, max 30 into amp, 30 max, below 1.5 SWR in a box. Max, dead key, from this amplifier. What they're saying is if you have variable dead key power on your radio, with the variable all the way open, you don't want to exceed 175 watts worth of carrier, which works out to be roughly about a watt worth of drive dead carrier. The gentleman that owns this box is a hell of a great guy. He's a friend of mine. I like him. He's a good cat. He sends me all kinds of goodies from the islands all the time. Nice man. Stand up dude. I opened this thing up before I even turned the video on, and I said, hey man, let's look at your amp. And I looked in here and I seen this resistor was burned up. When this variable is all the way open, the RF comes in on the mini coax, goes through this armature, goes through this armature attachment, then comes back out, goes through what? A voltage divider. And then this is our coupling back to ground, our reference for the variable potentiometer for in the opposite direction. Has that got any rough spots in it? No. The safest way to run these is with the variable all the way open and use your radio to control what the amp is doing. What a lot of guys will do is they'll take their Cobra 29, Cobra 25, whatever, and they'll have like a 2 or 3 watt worth of dead key, and then they'll take this variable knob and they'll start backing the dead carrier down. Well, the only place that RF can go is through this little 2 watt resistor. So let's say you're putting a 4 watt dead key into this amplifier. You start backing it down. That means 3 watts worth of power has to go back through this back through the variable resistor, and then back through this resistor to ground. This poor girl got overdriven. That's all there is to it. That's all there is to it. It got overdriven. Now there's quite a few things in here I want to go change. Primarily most of them is organization, but we're going to pull the bias resistors. We're going to lift those so we can have access to our 10 ohm resistors that are underneath them. We're going to pull these two transistors out. We're going to replace this resistor. We're going to replace this with a higher wattage resistor in the front. And I bet you this thing will turn on and run. Because these resistors are discolored, which means if we go and we measure them, they probably have fallen out of resistance tolerance just a little bit. We're going to go ahead and we're going to replace all 4 of these as well. And when these heat, what that's telling me is there's more drive going into the circuit than the circuit can actually take. And they'll also heat up once the circuit falls out of resonance, and then that's what causes this resistor to burn up because there's an imbalance, and yada yada yada, lick a schmack, smoke, knack. And then bottom line is too much drive, just too much drive. If you have a low power radio that does like 1 watt, goes up to about 25, 30 watts. This is the shit. This is the shit. Anything more than that, guess what? It's going to end up at a repair shop. Now, in the same breath, let's really look at it. Look at that. We got a heat sink that comes all the way back to the edge of the cabinet in the bottom of it. Comes all the way back to here. So the heat sink goes from here to here. Now, that's really important. There's some guys that used to build, well, he's no longer in business. He had a heat sink that would be just barely wide enough for the transistors to barely fit on, and it would be exactly this long. You got to have the full encompassing amount of heat sink. So to see the full amount of heat sink underneath the amplifier is good. We've got forced air cooling. Our on-off switch obviously is loose, and that's because the nut that's on the front has fallen off. If we look down in here at the on-off switches in the back, you'll see that the star washer that should be on the front is actually on the back of the switch. You see it in there? Well, star washer needs to be out here on the front. Otherwise that nut can back off and it'll fall off. No big deal, we can simply fix that. It's not a big problem. But good parts, good components for the most part in here equals good amplifier. So overdriven. Overdriven. This was obviously run without a meter. That's all this tells me right here. Okay. This portion of the final section quit, fell up, went into imbalance, and it burned up here. This portion, this resistor popping, tells me that they kept trying to key it or kept talking on it and didn't realize they had a problem. The RF that's coming out of the driver section is now going into an unbalanced load, and this resistor gave its precious life trying to protect the circuit and saying, hey, there's an imbalance here, and it's trying to keep the RF to evenly split, and it's not. It's all being offloaded to one side. The resistor sees the imbalance, it starts to heat. This got keyed a lot after the box blew up, and they had no clue it had gone down. No meters. They didn't know what was going on. They're running in the blind. Let's talk about these. Specifically these surface mount capacitors. We have seen this in the past by a couple different companies. There's a lot of electrical pressure that takes place on this capacitor. There's a reason that everybody uses metal clads in that particular location in the amp. They get hot. They get really hot. We have seen the SMA circuit get used before. The problem is the SMA circuit that they have used in the past was literally the cheapest surface mount capacitor that money could buy. So we've seen a lot of these where the SMA got so hot that it literally unsoldered itself and fell off. We've seen it where the SMAs got so hot that they've cracked in half, and that's what caused the whole box to go down. These are a little bit higher quality SMAs. I'm going to have to measure these. That's all there is to it. Just for the sake of safety, I got to unsolder these, pull them off, and put them on the capacitance checker and make sure neither one of these have fallen out of resonance. Now, there's another company that figured out that if you change the placement of the SMA, it makes a great deal in how the RF affects it, but it still electrically is relevant to the circuit. And they put phenolic boards on the top of their output transformers, and they put the capacitor back here. It serves two purposes. All this SMA is doing is it's making the circuit think that the surface area and the length of the transformer is longer. Well, if you add surface area to it and lay the capacitor back here, you're doubling down. You're actually increasing the frontal surface area of the transformer, one, but two, you're moving it farther away from the field flux at the front, and that's what causes most of the heating issue. So it's one half one way or the other. Now in the same breath, I've seen that same SMA that was back here on the transformer get hot, crack, burn up, blow up, and it's a high dollar SMA. And we're talking something that, and a surface mount capacitor that was like the size of a dime. I'm going to pull these off. We're going to check them. If they're a little bit out of tolerance, hey, we don't know if that's from it being overdriven. We don't know. But if they're out of tolerance, we're going to go ahead and pull these SMAs off. We're going to replace them with metal clads, and we're going to move on. So first things first, we're going to disconnect our bias circuit, pull this out. We're going to pull these two transistors out. We're going to take our 10 ohmers out, and we're going to slap two brand new HGs in here that are beta gain matched. We'll slap them in here, and then we'll be back. You know, the hardest part about being an amp technician is playing the politic game. Like, well, what do you mean, BBI? Well, amp guys are really emotionally sensitive, as far as I can tell. And you got to be really sensitive sometimes. And this is one of them deals where you got to be a little bit sensitive, I think. So I'm very going to carefully remove this. 250 degrees ain't gonna get this job done. Come on, let's go. Let's get this up here a little bit. Here we go. Okay. Carefuling. Okay. Let's get some hotter air going on. That's SMA number 1. That's SMA number 2. All right. Well, let's get out the old capacitance checker. Function, auto. Still within tolerance. This also still within tolerance. So, good. That's good. We know that's not the issue. Here's our 2 blown transistors that we have, and our 2 surface mount capacitors, and our two dead ohm or 10 ohm resistors. So we got this stripped down. We're going to neaten this up as we go back and put this back together. I got to have things tight and neat. It's just me, the way I am. So when we put this back together, I'll slam 2 new transistors in here that are matched, 2 new 10 ohmers, and then we're going to come by and we're going to tighten this up a little bit. We're going to tighten this up a little bit. We're going to trim off some of our long wire leads in here that might make contact. Trim this back a little bit, shorten this up a little bit, shorten this up a little bit. We're just going to neaten it up. We're going to replace this resistor over here. It's all smoked. And I wanted to take a minute and show you this bias circuit and how this works up inside of here. This is kind of cool. So, this is pretty neat. So we have our constant 12 volt hot that comes in on this wire. Well, this is an inductor choke, just a long piece of wire wrapped around a ferrite, and it keeps the RF from trying to run this direction back to the power wire. But the 12 volt DC can run right through this wire and run up to this tab on the relay. Okay. Now in reverse, what happens is when this relay closes, it makes contact with this tab, 12 volts runs up this green wire, and it is set aside from running outside of the cabinet from this disc capacitor. See that? So 12 volt runs up this disc capacitor, and we run through this wire choke, which keeps the RF from trying to run up this wire, and it runs over to our bias. So that's how we have our switched 12 volts. We're using one relay to do the job of 2. And we're putting the RF and the 12 volt DC together, and we're playing the separation game. In the same turn, this capacitor acts as a blocker. It keeps the 12 volt on this side of the capacitor. The RF can pass through this disc capacitor, then run down our coax and go to our input for our 2-pil section. The same thing is going on back here. This is our capacitor that charges our keying relay. The RF can come in, fly through this capacitor, come back down and go through our green wire, and it can pass through here, or it gets switched, it goes through, passes through this disc capacitor, and then it runs on down to the input. It's pretty neat. It's a total of 5 extra parts. A sum total of maybe $2. This is not the way I like to do things. I'm just showing you this is how this circuit is laid out, and with the use of a tuned inductor as a blocking circuit and disc capacitors, otherwise capacitor's primary job of blocking DC current, capitalizing on those 2 things, resonancy factor and then isolation factor with the capacitors, you can achieve the same thing as having the relay that I like to use set off over here by itself. I'm saying that's what it is. That's what it is. Now the last thing I got to do before I go and do all those repairs is I have to fix this. That little white clear tape doesn't work too hot. It just wants to pop right off. So we're going to take this relay apart real quick, as we're going to unsolder most of these connectors. We'll flip it up and we'll put 3M commercial grade double-sided stick tape on the back side of that, so we don't have to worry about this popping out and floating around at all. So we'll get this repaired as well. So we'll do this, and we'll come over and do all of this, and we'll fix all of this, and then we should pretty much be ready to go and give it a whack to see what happens. So we made some significant changes on the inside of the box. Well, not significant, no. Let's be real about it. It's not significant. It just made some changes. I'll show them to you here in a second. But the last little bit we got to do is we got to get rid of that 50 amp Anderson clip, right? So that, and he's using real power wire. That's real good cable. This one here is Stinger Pro. We know a guy that's using Stinger Pro, don't we all? I do. I've met him. I've even seen him naked. Looks a lot like myself. Anyhow, he's using good power wire on here. So for a change, I don't have to switch hit that up. There it goes. So this amp actually belongs to a friend of mine in Hawaii, a guy that I really, really like, and has treated me very well, and I've done a lot of business with. So in turn, because it is going all the way to Hawaii, I made some changes in here that make me feel comfortable. Okay, because at the end of the day, my name now is attached to this. It's not just the Carl-built name on the inside. So, one of the changes I made is I got rid of this blue straight out of Alibaba capacitor for the tuning cap. It's still well within tolerance. Let me show you what I mean. Let me zero my little capacitance meter here. We'll hook this cap back up. I mean, that little blue Alibaba cap is still well within tolerance, but to make myself feel better about it, I went ahead and we changed it out to a metal clad. The SMA capacitors up here, still well, all within tolerance. Totally viable chips. To make myself feel better about it, I used the oversized metal clads. I went ahead and I tightened all of this up. I went in here and I took the bias and I made it so they snuggle down on top of the transformer. And we're going to kick these caps just a little bit forward. Remember, the fan sits right above this blowing air in. So we don't have to worry about too much of the resistors overheating the caps and knocking them out of tolerance. So just kick them forward a little bit and air blows right on them. If you guys remember, when I took this all apart, this was all standing up and floating around free and could bump into a bunch of stuff. Well, we've got our flyback resistor here. We've got positive 12 volts over here. We've got our output and input voltage divider. Then above that, we've got yet another 12 volt source. There was too much stuff in here that could just float around and bump into each other. That's the way it came, that's the way it was made. It didn't make me feel comfortable, so I wanted to change it. The other thing that I have to change, and this is a huge safety concern, was the wire that comes off of this choke and feeds this circuit. This is the old piece of wire. Now, this is stranded, but it's PVC based wire. I don't want to put the nick there, we'll put it here. And what do I mean by PVC based wire? Is it melts and it's soft. I can strip it with my fingernail. Okay. This is a relatively new box. And right here, see this little black dot here? This is where it was rubbing against this shorting bar right here. You can see it was laid in here like so. This wire was making contact with this choke, and it was sitting there rubbing against this little tiny carryover bar that you put in there to hold stuff down and keep things neat. I didn't feel comfortable with that. Okay. So I changed this out to PTFE wire, silver plated, stranded, Teflon wire, heat resistant, rub resistant, military standard wire. Change that out. Everything else in here seems to be Teflon, like this green wire, because it's positive, it's Teflon. This power wire here is Teflon. This is Teflon. This is Teflon. All of this is Teflon. But for some reason, this one wire was not. I didn't feel comfortable with that. So for my mental well-being, and knowing that this is going to Hawaii, which is a small fortune to send shit back and forth from Hawaii, I changed it out for my mental well-being. So I feel better about it. I feel comfortable with it because my name, like I said, my name's associated with it. So changed out the 2 transistors. I keep very few 2-watt resistors in the shop. I don't like them. It's a personal thing with me. 5 watts is better. You're never going to change my mind. When shit goes wrong, the only thing that's protecting your circuit from an imbalance is the size of this resistor and these resistors. 5 watts work better, 2 watts is adequate. So I don't keep a lot of 2-watters around here. I think I got maybe 15 or 20 left. I got to order more. So we just went ahead and changed everything out to 5 watt. The 50 ohm resistor that was here that was 2 watts, we supplemented that with 2 5-watt resistors in parallel at 100 ohms apiece, so that gets us 50 ohms, but at 10 watts worth of dissipation. So all we did is make it so that the next component in line will take the brunt. If this box gets overdriven again, it's going to burn the variable up, or it'll burn this divider up. But these, not a problem anymore. So that's fixed, this is fixed, this is fixed. All of this is tightened up and down tight. It can't come up anymore. This can't move around. None of this stuff can bang into each other and cause us to have an electrical short of any kind. Trimmed and shortened, like the combiner leads here, they were twisted, which is good, and so the wires are twisted around each other, right? But the leg length was so long that it was just like maybe like 1/16 of an inch away from shorting out from here to here. So I trimmed that back, trimmed this one back, pulled the 220 puff cap down, and then I made it so that the combiner wire, the wire that comes out of the 2-to-1 port combiner, is actually permanently long. It's long enough that it's sitting underneath this wire wound resistor. I shortened this resistor up. Instead of having it sit way over here, I pulled it back, shortened the leg up so that the combiner is now resting underneath this resistor, and there's no way that the combiner can move up and down. Keep it tight, low to the cabinet. This capacitor leg that goes from here to here, I pulled that up and twisted those wires, all 3 of these wires together. The 2 leads from here, the lead from here, and the lead from the capacitor length going down. Which this circuit here, all this does is help, once again, add more capacitance to the circuit to help it throw it more out of resonance, and it just snubs the RF right to ground, if any does actually manage to make it on this circuit, which very little ever does, but it's still there. So that's what's going to keep this from moving up and down. The resistor placement here will keep the splitter from moving back and forth. The nose length of the combiner underneath the resistor will keep that from moving up and down. So all of this stuff is pretty well locked in and it's not going to move. If you can see, we've got a lot of stuff going on in a tiny little small space. Turn the exposure up. It's a little tight in there. And the chances of having something bump or rub or touch each other is pretty high. So I wanted to mitigate that risk. I wanted to minimize it. We took the key and relay all apart. We've got that now held down with commercial grade 3M black or gray double-sided stick tape. That relay's not coming off. And the last little bit of this dog and pony show that we got to do is these coax connectors. Or coax connectors. Can you tell it's 12:30 at night and I've been out here talking and working since 9 o'clock this morning? It's been a long day. A lot of people had a lot of things to tell me today. It was an interesting day. I'm here to tell you what. Phone never stopped ringing. You guys, I apologize to you. I try so hard when you all call to not be the, yeah, what do you want? I try to be interested and entertained, but you also got to understand that like I got guys that try to call me and they want to BS for like 3 hours, and I don't have the time, as in like I can't sit here for that long on the phone. I can't. So I try to keep each conversation about 10 minutes. There's quite a few of you guys that pick my brain. Like I had this guy's name's, I've been calling him Bob now for almost a year. Today, I called him back, he didn't answer, and I got his voicemail, and, hey, this is Charles. Leave a message. And I'm like, Charles? Who's Charles? Your name's Bob. He calls me back. He goes, no, man, my name's Charles. I said, so you've just been putting up with it? He goes, yeah. I'm like, dude, don't do that. The point is, Charles has got himself yet another project amplifier, and I'm trying to, I helped him through an SB220 repair. Taught him a bunch of different tests that you can do. And now he's got that SB220, it's his bitch. He's got it mastered, right? Well, now he's decided that he's going to go buy another project amplifier. And hey, I'll call my buddy BBI and he'll help me walk me through it, and I'll figure out how to repair it myself. I've got dozens of dudes like that. I don't mind it, but when I'm super busy, I can't spend 2 hours on the phone with you each day going through it. So today was just a busy day. Just a busy day. Fun day though, very educational. Learned a lot about a couple different people. It's okay. So we're gonna get off the little 50 amp Anderson clip. We're gonna go to the 175, which should help us fall within at least our current draw length, or current draw range. Man, I'm getting tired. Why do we always use marine grade heat shrink on our joint? Because we want to mitigate if there's any solder that's managed to make it up here into the wire. We want to help support that joint. Always heat shrink. Anything bigger than 8 gauge, you've got to hydraulically crimp it. Because just the vibration of the connection alone, the wire's so big that it'll eventually, like this here, this has to be hydraulically crimped. This is 1/0, 2/0. It was a Stinger Pro 1/0. This is 1/0 gauge cable. So these eyelets have been hydraulically crimped. There's enough torque in the connection that it will eventually work itself free, but this little guy, not a big deal. So let's get on with it. Power supply on. Come over here. Turn our peak kit, make sure we're on 1X, forward reflect. 1,000 watt slug going forward in PEP, 1,000 in average, 5 watt slug in reverse. Okay, so it's a good sign. Everything lights up the way it should. Oh yeah, talking right through it, no problem. Hello, audio. Perfectly flat pass-through standing wave, which is good. So, hello, audio. 25 watts max. 30 watts max going in this thing. I'll show you this too. Remember how I stressed to you that this is an incredibly low drive amplifier? The whole first portion of this video? We're going to put a half a watt in it. It's as low as my 2950 will go, as a half a watt. Half a watt. 200 watt carrier with half a watt going in. Hello. Gets up there, does about 9 and some change, which is what this thing should do. Period. 900 to 1,000-ish. We could probably get a little bit more out of it if we changed our tune just a little bit, but we're going to leave it alone. I know that this is working well with this guy's antenna. He's going to be happy. It's all fully back up and running. Didn't really change a whole lot in here, just did some stuff for safety to make myself happy. Tightened everything up, cleaned everything up, made it a little bit more organized. Hello, audio. Hello, audio. We're driving the poop out of these transistors. I mean, that's 200-ish watts going, 250, maybe almost 300 watts going into these 4 transistors. That's a lot of drive. A lot of drive. Hello. 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 So come here. Hello. Hello. It's peaking over 900. So it's working. It's doing its job. Now there's one more thing I got to do. And once again, this is a personal safety thing. Oh, I miss using these never cool ever cools. You guys see it yet? It has to do with this portion of the unit here. Just ponder it for a second. Ponder it just for a second. I'll get the part out here. No resistor on the fan ground. Gotta have it there. It's gotta be there. Figured it out. We know why it's there. We've talked about it in many videos. If you don't believe me or don't know what I'm talking about, go listen to the tips and tricks on how to build a 4-pill amplifier video, where I discuss how you can help protect the electronics in your fan by adding a simple 3 ohm resistor or a 1.5 ohm resistor, 2 watts or bigger, to your ground lead on, you know, your half amp or 1 amp fan, and how to keep the RF out of the electronics inside, making it proof positive the fan will run forever. No BS now, guys. Back in the day, I used to love my 2x4 I had. It was built by X-Force. And it was built by Carl and the boys. Old school, gray label, good stuff. Carl built. We came up with the name Carl built a long time ago. And it was me and Brian Smith, and we were sitting on the phone, and I'm not taking credit for the company name. Don't get this wrong. Do not get this twisted. I'm on the phone with Brian Smith, and we're talking about how the quality of X-Force had just gone in the crapper. And I said to Brian, I said, man, I wish that we could get the same style of components and the quality that we got back when Carl was building the boxes. I said, you know, kind of like Carl built. And he goes, yeah, that makes perfect sense. And at the time, he was trying to sell an X-Force 16 pill gray label. And I said, Brian, you know what you got there? You got yourself a Carl built box. He goes, what do you mean it's X-Force? I said, no, it's a Carl built box. He goes, oh, I get you. And so from there, we started trickling it out. I started using it in the YouTube videos. And Brian, when he went to advertise that amplifier, I'll never forget this a day in my life. I'll never forget this. He goes and he advertises the amplifier and he says, this is a real deal, genuine X-Force built by the guys back when Carl was running the business. So I guess it would be Carl built, is what he said. And Arlen snapped right back. Well, Brian Smith, I don't know what you mean, because the exact same people that were here working for Carl are here building for me today. Just saying. That term Carl built means a lot. It did then, it did for decades before, and I'm really glad that him and the guys are all working together again. And I'm here to tell you the quality between this and the Blue Label X-Force, there is no comparison. The guys are back. It's a fact. There's going to be detractors that are going to come along and they're going to use big words and think they're going to sound important, and I'm going to shoot them down right now. But BBI, you sure repaired a lot of X-Force equipment that's got gray labels on it. I've repaired a lot of everybody's equipment. You got to remember, there's a lot of X-Force amplifiers out there. There's a lot of Fat Boys. There's a lot of Dave Maids. There's a lot. But I repaired a whole lot more Blue Labels. I'll say that too. Gentlemen, my name is BBI. Without a shadow of a doubt, I am the biggest mud duck in Idaho. Come check me out, www.bbiamps.com. Come find me on Facebook, BBI Amps the group. 35, 40 posts a day. Our latest achievement as a group is we single-handedly talked a guy step by step through repairing his SB220 just with pictures and text chat in the group. He got his family's SB220, his granddad's SB220 up and running. Really quite proud of that. Come join us. It's fun. Big shout out to Siglent. Big shout out to Excess Power. Oh! I got some cool new tech coming for you guys from these guys. Game-changing technology. And I can't wait to bring you guys all up to speed on it. You're going to freaking love it. Your mind's going to be blown. Completely change the game. More than super capacitor change game. I'm here to... Cool shit coming. Cool shit coming. And last but not least, but the absolute most important, hey guys, thanks every single one of you guys for tuning in and watching. I appreciate it. It means the world to me. On to the next show we go. We'll see ya. Bye-bye.